Hello, in this video we are focusing on just practice. So if you're looking for instruction, please check one of the videos in the description. So we are practicing factoring quadratic expressions where a equals 1. So when the leading coefficient is equal to 1. In this situation, we're looking for two numbers that multiply to C and add to B. So we're going to take factors, draw a little factor tree of C. So what multiplies to C? All the factors. Well, we're always going to start with 1 times whatever C is. And then we check, does 2 go in, does 3, does 4, and make a complete chart of all of the factors. And then we pick the factor pair that adds up to our B value. Now keep in mind that two numbers that multiply to a positive can either be both positive or both negative. So keep that in mind while we're factoring. Our first quadratic expression, a equals 1 and b equals 4. So let's just write that out. Let's try that again. A equals 1, b equals 4, c equals 3. We're looking for two numbers that multiply to c and add to b. So with this expression, it looks pretty easy. 1 and 3 are the only factors of 3, and we can see that pair adds up to 4. So the way that we factor this expression would be x, they're both positive, so plus 1, x plus 3. Our next quadratic, looks like we're using a different variable here. That is not a problem. We still have the same process. So again, a, b, and c. A is 1, b is 8, and c is 7. So we're looking for factors of 7 that add up to 8. And since 7 is prime, we only have one pair of factors and positive for both of those. They both add up to positive 8. So we factor this as y plus 1, y plus 7. Our next quadratic is in terms of m. We have a equals 1, b equals 12, and c equals 11. So again, we're looking for factors of c that add up to b. And the factors of c in this case are just going to be 1 and 11, because 11 is prime. That's our only factor pair, and the positive of both of those two would add up to positive 12. So we have m plus 1, m plus 11 would be our factors. Okay, so starting from this point forward, I'm not going to list out the a, b, and c components. We can just jump into factoring. We're looking for factors of 13 that add up to 14. Well, 13 is a prime number, and there's only one factor pair. So we have b plus 1, b plus 13. All right, so now we're dealing with a c value that is not prime. So if we list out all the factors of c, we'll get 1 and 20, 2 and 10, 4 and 5. And we're looking for a factor pair that adds up to positive 9. And it looks like that's going to be 4 and 5. So a plus 4 a plus 5 would be our factored expression. All right, m squared plus 7m plus 12. We're looking for factors of 12 that add up to 7. Well, 1 and 12 are both factors. 2 and 6, 3 and 4 are factors. And it looks like 3 and 4 will be our pair that add up to positive 7. So m plus 3, m plus 4 will be our factored expression. P squared plus 11p plus 30. So we're looking for factors of 30. We got 1 and 30. Always start with 1. We have 2 and 15, 3 and 10, 5, yes, 5 and 6. Since I know that there's no numbers, at least no whole numbers between 5 and 6, I can stop there. So which pair add up to positive 11? It looks like our last factor pair, 5 and 6. P plus 5, P plus 6 will be our quadratic in factored form. W squared plus 10w plus 21. Okay, so factors of 21. 1 and 21. 2, 3, yeah, 3 goes in. 3 times 7. 4, 5, and 6 don't go, but that's okay because I've already got my factor pair here. 3 and 7 add to 10. So I can write this in factored form as w plus 3, w plus 7. And we are done. N squared plus 19n plus 49. Okay, so we're looking for 49. I said 49. 48. So we're looking for factors of 48. I always start with 1 and 48. I know 2 because this is an even number. Let's see, 2 goes in to 40, 20, and 8, 4, so 24. 3 goes into 4 once, and then goes into 18, 6, so it goes in 16 times. 4 goes in. 4 goes into 40 10 times, and 8 twice. That's 12. 5, no. 6, yeah, 6. 6 times 8 is 48. Okay, so now let's look for a factor pair that adds up to positive 19. And we have it right here, 3 and 16. I can write my factor, or my factored expression as n plus 3, n plus 16. And we're done. Next expression is b squared plus 14b plus 48. So I'm looking for factors of 48. Always start with 1. Yep, 2. I know from our last time 2 times 24 for the last example. I know that 3 times 16, 4 times 12, and then the next one would be 6 and 8. Okay, and factors that add up to, factor pair that add up to 14. Well, that's clearly going to be 6 and 8. We've got b plus 6, b plus 8 is our expression in factored form. Next example is a squared plus 25a plus 100 plus 100. So we have 100, and we're looking for factors of 100. We have 1 times 100. We have, it's even, so 2 times 50. 3 does not go into 100. 4 does. 4 times 25. 5 goes in 20 times. 6, no. 7, 8, 9, 10. Yeah, 10 goes in. Okay, so now since we've exhausted, there are no more numbers between 10 and 10. Clearly, we know we've exhausted our factors, and it looks like 5 and 20 will add up to 25. A plus 5, a plus 20, and we are done. u squared plus 101u plus 100. Again, factors of 100, 1 and 100, 2 and 50, 4, 25, 5 and 20, 6, 7, 8, and 10, and 10. Looking for factors of 101. Well, that's right up here at the very top. So we have u plus 1 times u plus 100 will be our factored expression. X squared minus 8x plus 12, factors of 12, 1 and 12, 2 and 6, 3 and 4. And we are done. We have reached the end. And which pair can add up to -8? Well, this one's a little bit tricky. 2 and 6 add up to +8. Well, let's see. We need two numbers that multiply to +12. Oops, to +12. Okay. Well, we can either have 2 times 6 equals 12, but also -2 times -6 equals +12. So if we just make that a negative and a negative, that will add up to -8. So that will be our pair. X minus 2, x minus 6. We are done. Q squared minus 13q plus 36. Very well. We are looking for factors of 36. 1 and 36 is what we start with. It's even, so I know 2 goes in. Looks like 2 is going to go in 18 times. 3 goes into 30, 10, and 6 twice, so 12. 4, well, I already know 4 times 9, and 5 doesn't, but 6, yeah, 6 squared is 36. We're looking for factors that add up to -13. Given that that both of these are positive on both sides, or both of these are negative, which pair can add up to -13? Well, it looks like if we have -4 and -9, that will add up to -13. So we have q minus 9. Oh, I wrote it backwards. That's okay. Q minus 4. So q minus 9 times q minus 4. Y squared minus 18y plus 45. 45 factors. 1, 45. Not 2, 3. 3 goes into 45 15 times. 4, I know 5 goes in. Let's see, 5 times 9. 6, no, 7, 8. Nope. Okay, so I think we're done. Okay, which pair can add up to -18? Given that we multiply to a positive, that means that both a pair needs to be positive or they both need to be negative. Well, in this case, they need to be negative. So y minus 3, y minus 15 would be our factored expression. M squared minus 13m plus 30. So we are looking for factors of 30. 1 and 30, 2 and 15, 3, 10, 5 and 6 are our factor pairs. Again, we have a situation where we're multiplying to a positive and we are adding to a negative. So it looks like both of our factors are going to need to be negative, -10 and -3. So we have m minus 3, m minus 10 will be our factor pair, or factored expression. X squared minus 8x plus 7. So we have factors of 7. Well, 1 and 7, and that's it. Okay, Okay, multiply to a positive, add to a negative. They both have to be negative. So it's going to be x minus 1, x minus 7. Y squared minus 5y plus 6. So we're looking for factors of 6, 1 and 6, 2 and 3. That's it. And we have multiply to a positive, add to a negative. These must be negative. So y minus 2, y minus 3. Next expression, p squared plus 5p minus 6. So multiply to negative 6. And I'm not going to worry about the negative because I'm just looking for the factors of the absolute value. Because otherwise I'll be listing 1 and 6, or sorry, 1 and negative 6, negative 1 and 6, 2 and 3, negative 2 and positive 3. So I'm just going to list out the positive factors, or the factors of the absolute value, and just keeping in mind that it has to multiply to a negative 6. So one of these, either one of those or one of those, has to be negative. Well, I'm adding to positive 5, so it looks like negative 1 and positive 6 would fit the bill. So p minus 1, p plus 6 would be the factored expression. N squared plus 6n minus 7. So we're multiplying to negative 7. 1 and 7. Okay. We know it multiplies to a negative, so 1 or 7 have to be negative. It doesn't matter which. But in this case, we have to add to positive 6. So it has to be a positive 7 and negative 1. So we have n minus 1, n plus 7. We are done. Y squared minus 6y minus 7. So again, negative 7. And we have, well, there's only 1 and 7 are the only factors. This time we're adding to negative 6. So instead of a negative 1, we need to have a negative 7. Fair enough. Y plus 1, y minus 7. V squared minus 2v minus 3. So negative 3. 1 and 3 are the only factors. Looks like 3 is going to have to be negative if we want to add to negative 2. So v plus 1, v minus 3. X squared minus x minus 12, negative 12. We have 1 and 12, 2 and 3. Oh, not 2 and 3. 2 and 6, 3 and 4. And multiplies to a negative, so one of the factors have to be negative. Adds to negative 1, so I think we would have to use negative 4 and positive 3. We have x plus 3, x minus 4 would be our factored expression. R squared minus 2r minus 8. Negative 8. We have 1 and 8, 2 and 4. Which pair can add to negative 2 given that one of these factors have to be negative? Well, if we use negative 4 and positive 2, that would fit the bill. So r plus 2, r minus 4. A squared minus 3a minus 28. Negative 28. So we have 1 and 28. 2 and 14. 3 doesn't go in, but 4 goes in. 4 times 7. 5 and 6 don't go in, so I know that that's the end of the line. Which pair can add to negative 3, given that one of the factors have to be negative? It looks like it's going to be -7 and +4. A plus 4, A minus 7. We are done. B squared minus 13b minus 30. So -30. We have 1 and 30, 2 and 15, 3 and 10, 4, no, 5 goes in 6 times. And we are done. So we're looking for a pair that add up to -13, given that one of the factors have to be negative. It looks like -15 and +2. So b plus 2, b minus 15 would be the factored expression. W squared minus 5w minus 36. So -36. We have 1 and 36, 2, 18. 3 goes in, let's see, 3 goes in 12 times. And the 4 goes in 9 times. And 5 doesn't, but 6 squared is 36. Given that one of them has to be negative, again, because we're adding to -5, it looks like the factor pair would be -9 and +4. So w plus 4, w minus 9. Here we have t squared minus 3t minus 54. So -54 factors are going to be 1 and 54. I know 2 goes in. Let's see how many times. 2 goes into 50, 25. 4 twice, so that goes in 27. Does 3 go in? Well, 3 goes into 5. 3 goes into 5 once, with a remainder of 2. And then 3 goes into 24. Right? If we put the 2 in front of the 4, 24 goes into that. Oops, I'm writing it the wrong side. It goes in once, and then it goes into 24 8 times. So 3 times 18. Does 4 go in? 4 does not go in. 5, 6. I know 6 times 9, and then 7 and 8 don't go into 54. Well, we're looking for a pair that add to -3. And it looks like if I have -9 and +6, that will multiply to -54, and will add to -3. So t plus 6, t minus 9 is factored form. Okay, x squared plus x plus 5. So we're looking for factors of 5. Well, 5 is prime, that would be 1 and 5. And we want a pair that add up to +1. Well, does not matter if we choose 1 times 5, the positive. That would multiply to +5. And we could also look at the negative. -1 times -5 also equals +5. However, neither of those pairs adds up to +1. Okay, so looks like this technique is not going to work in this situation. This quadratic here is called prime. Similar to similar to 5 being a prime number, we cannot factor 5. We cannot factor this expression into two binomials. Now later we'll learn how to factor this using some other techniques, and we'll end up with some imaginary solutions. But you can look at the videos in the description for those techniques. X squared minus 3x minus 9. Okay, we're looking for factors. Oh, don't want that highlighter. We want pen. We're looking for factors of 9 or -9 that add up to -3. Well, 1 and 9, 3 and 3. Now, it doesn't matter, it looks like it doesn't matter which of these factors is negative. Neither of these pairs can add up to -3. This quadratic is also a prime. So please look in the description. Again, you can find videos on how to factor this. Okay, so 8 minus 6x plus x squared. Well, we know that our standard form is ax squared plus bx plus c. So I think we should rewrite this so that it's in standard form. So let's write that with our x squared term first, our linear term second, and our constant last. Okay, so now that it's in standard form, it jumps out that c is 8. Looking for factors of 8, 1 and 8, 2 and 4. Multiply to a positive, add to a negative. Okay, they both have to be negative. Okay, -2 and -4. So x minus 2, x minus 4 would be our factored expression. 7x plus x squared plus 6. Okay, well, c's in the right position, but bx and ax are not in the right position. So again, ax squared plus bx plus c. Alright, so let's rewrite that. It's going to be x squared, put our linear term next, 7x, and then our constant. Okay, so now we're looking for factors of 6, 1 and 6, 2 and 3 that add up to positive 7. Well, looks like 1 and 6 will fit the bill. 1, or x plus 1, x plus 1, and x plus 6 would be our factored expression. X squared minus 11 minus 11x. Let's go ahead and write that in standard form. That would be our quadratic term first, linear term second, and constant third. Now we're looking for factors of -12, 1 and 12, 2 and 6, 3 and 4. Multiply to -12 and add to -11. Well, one of these factors has to be negative. If we make -12 or 12 negative and 1 positive, that would work. So x plus 1, x minus 12 would be our factor pair. -11 minus 10x plus x squared. I'm going to write that in standard form, where ax squared plus bx plus c. So I'm going to write my quadratic term first, my linear term second, and my constant term last. So I want factors of -11. Well, factors of 11 are 1 and 11, and that's it. We want to add up to -10. So it looks like if I use a -11 and a +1, that would work. So +1, x minus 11. Okay. Very good.